Hello friends, this video on structure of atoms part 12 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 11. We have to find the number of electrons in 1 mole of methane. 1 molecule of methane is how much? I'll show you. I have to find number of electrons. So 1 molecule of methane, if you take first, has how many electrons? Methane is CH4. So carbon will have 6 electron, 1 carbon, plus hydrogen is 4, correct? 1 hydrogen has 1 electron, therefore hydrogen electrons. So 1 mole of methane has 10 electrons. I have to say 1 mole of methane, 1 molecule of methane has 10 electrons. I know 1 mole of methane is nothing but 6.023 into 10 to the power 23 molecules of methane. I hope you understand this. And these many molecules of methane means nothing but 6.0, the same molecules into 1 molecule is how many? 10 electrons. So these many electrons. And that is my answer. So if you solve this becomes 6.023 into 10 to the power 24 electrons. Hope you understand this. See, 1 mole of methane, 1 molecule of methane has 10 electrons. And 1 mole of methane has these many molecules of methane. I have to find the number of electron in 1 mole of methane. So 1 mole of methane is equal to this many molecules of methane, and 1 molecule of methane is 10 electrons. So these many molecules of methane means these many molecules into 10 electrons. Find total number and total mass of neutrons in 7 gram of carbon 14. And you assume that the mass of neutron is. So please note, here we are looking only for neutron. Neutron is our hero, correct? And we have to find the number and mass of neutron in 7 milligram of carbon. First, let's see, 1 atom of carbon has how many? Neutron has how many neutrons? So if you see, this guy has, this is 6. So this guy has how many neutrons? Neutrons is nothing but my atomic mass minus atomic number. That is 14 minus 6, that is 8 neutrons. Hope you understand. So 1 atom of carbon 14 has 8 neutrons. Now I talk in grams. How to get in grams? I know that 1 mole of carbon 14 is nothing but 14 grams of carbon 14. So with this I can get something in grams. And 1 mole of carbon 14 is nothing but 6.023 into 10 to the power 23 molecules of carbon 14. And 1 molecule or 1 atom of atom I'll say, atom of carbon, correct? And 1 atom of carbon has how many neutrons? 8 neutrons. That means my 14 grams of carbon will have 6.023 into 10 to the power 23 into 8 neutrons, correct? Because this has this many atoms of carbon and 1 atom of carbon has 8 neutrons. This many neutrons we have in 14 grams of carbon 14, right? But we are looking for 7 milligrams. This is 14 grams. So 7 milligrams of carbon 14 will have how much? This is gram, this is milligram. So let's convert this into milligrams. This becomes 14,000 milligram. So 14,000 milligram has this many neutrons. 7 milligram will have how many neutrons? Very simple math. We'll do this. 10 to the power 23 into 8. Divide this by 14,000 and multiply by 7. Correct? And if you solve this, you'll get answer as 2.4092 into 10 to the power 21 neutrons. So the number of neutrons we have is almost 2.4 into 10 to the power 21 or 7 milligram of carbon 14. Correct? Easy only. See, The logic is you have to first find how many in one atom how many neutrons we have. Since we are talking about milligrams, we know the relation between grams and moles. We know 1 mole has how many atoms, and with that you can find the value. The second part is you have to find total mass. So total mass is now simple. Is number of neutrons we have into mass of neutron. So number of neutron what we have is this much, 2.4 into 10 to the power 21, and mass of neutron is given this guy, 1.675 into 10 to the power minus 27 kg. So you multiply both and you get something as 4.03 into 10 to the power minus 6 kg, and that is my answer. Let's take one example. So we have to find total number and total mass of protons. Please note here the hero is proton for 34 milligram of ammonia at standard temperature. The question is, will the value change if you change temperature and pressure? Similar question, instead of neutron we have proton here and we have ammonia. Same thing we'll do here. So one molecule, first we'll find one molecule of ammonia, where I wrote molecule because ammonia is a molecule actually, not an atom. Has nothing but nitrogen will have 7 proton plus hydrogen will have 1 each, 1 into 3, 10 protons. So one molecule of ammonia has 10 protons. Same formula we have, 1 mole of ammonia is equal to 17 grams of ammonia, right, is equal to 6.023 into 10 to the power 23 molecules of ammonia. So why I wrote molecules? Because it is NH3. So this is molecules. Now I am asked 34 milligram. 17 gram is this many molecules, and these many molecules has these many molecules into 10 protons. 6.023 into 10 to the power 23 into 10 protons here, right? I'm looking for protons, and that is 17 grams. So I'll write 17,000 milligrams of NH3. I'm looking for 34 milligrams, right? So my 34 milligrams of NH3 will have these many protons, divide by 17,000 into 34. So what you get is 1.2046 into 10 to the power 22 protons. So these are the number of protons I have. Finding mass of proton is very simple. Same thing. Mass of proton. Total protons is nothing but mass of one proton into number of protons. So what is mass of one proton? It was given in the last question also. That is 1.67493 into 10 to the power minus 27 kg. And number of protons we have is this guy, 1.2046 into 10 to the power 22. So you multiply this, you get 2.0176 into 10 to the power minus 5 kg. Now the question is, will the value change if you change temperature and pressure? No. Why? Because it doesn't matter which temperature you're looking for. The number of protons is same and the mass of proton is same. The number of protons is same, the mass of proton is same, doesn't matter which temperature and pressure we are looking for. The answer will be same. How many neutrons, protons are there in this nuclei? Carbon, if you see, 6, 13. So if you see, neutrons and proton I have to find. So proton is nothing but my atomic number. So my proton here will be 6. And neutron is nothing but my atomic mass, my atomic number, that is 13 minus 6, that is 7. Let's take this guy, oxygen, 16, 8. Here also my proton will be this guy, 8. And my neutron will be 16 minus 8. Similarly here, manganese, I have 12 and 24. My proton will be atomic number 12 and my neutron will be 24 minus 12. Correct? Proton means property, power, and atomic number decides, proton decides probability. Correct? Let's take one last example of atomic number, atomic mass. So you define the complete symbol for this atoms with atomic number, atomic mass given. So atomic number is 17, that means it is chlorine, and you have 35. First part is done. 92, that is this guy, and 233 is given. 4 is beryllium, atomic mass is 9. And that is my answer. Very simple. This question is just about asking you whether you know that 17 atomic number means chlorine and 4 atomic numbers beryllium. That's all.
Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.